Let's look at number 2. I have the indefinite integral of x plus 1 over x minus 2 times 2x minus 1. The first thing I need to do is set up that partial fraction decomposition. So I take this rational expression and I say x plus 1 over x minus 2 times 2x minus 1 is going to equal, this guy here is linear, and since it's linear, I'm going to put it over a constant, so a over x minus 2 plus, well, this guy here is still linear, so I'm going to say 2x minus 1 over a constant, b. Now what I'm going to do is multiply through by the denominator. So I'm going to multiply this guy here by that x minus 2 times 2x minus 1, and then the whole entire thing over here by x minus 2 times 2x minus 1. The denominators are going to cancel on the left, and I'm just left with x plus 1. When I distribute to my first term, the x minus 2's cancel, and it's just a times 2x minus 1. And when I distribute to my second term, the 2x minus 1 cancels, and it's just b times x minus 2. Now for this problem, instead of using convenient values, I'm going to go ahead and do a system of linear equations just to show you something different. What you do when you're doing a system is you distribute and then you collect your terms. I'm going to distribute first. This becomes 2ax minus a plus bx minus 2b. Then I'm going to collect my terms, all my x terms together and all my constants together. So I have x plus 1 is equal to, well, if I collect my x terms and factor out an x, what would I be left with? A 2a plus b. And if I collect my constant terms, what would I be left with? A negative a minus 2b. Now, notice this equal sign, the equal sign between these two things. What this is saying is that x plus 1 has to equal x times 2a plus b plus negative a minus 2b. If this is x and this is x, then this guy here has to equal the coefficient of x. Well, there's no number in front of x, so it's that implied 1. So that means that 2a plus b has to equal 1. And this guy here is the constant term, and so this has to equal the constant term. Well, that's a 1, so I know that negative a minus 2b has to equal 1. Now I have a system of linear equations. Well, I'm going to show you how to do the system of linear equations in the calculator. Even though this one's pretty simple to do by hand, we're just going to learn the calculator method for it. Before I put it in the calculator, let's make it into a matrix first. When I make it into a matrix, I set up my matrix here. And I know that in this column I want all the coefficients of A. In this column I want all the coefficients of B. And in this column I want what I'm equal to. I want the answer here that I'm equal to. For this first equation, the coefficient of A is 2, the coefficient of B is 1, and I'm equal to 1. For this second equation, the coefficient of A is negative 1, the coefficient of B is negative 2, and I'm equal to 1. Well, this over here is what I'm going to stick into the calculator. So let's grab the calculator and put this matrix into the calculator and have the calculator find our answer for us. Grabbing our calculator, we're going to hit second and then the x to the negative first key for matrix. And we're going to put this in our matrix. So we have to scroll over to edit, and then we're going to hit enter because we're going to put it into matrix letter A. Now it asks you, well, what kind of matrix are you looking for? Well, this is trying to figure out how many rows and how many columns do you have. Well, if I look here, I have 1, 2 rows, and I have 1, 2, 3 columns. So again, I have 2 rows and 3 columns, so I'm going to put in a 2 by 3. So 2, enter, 3, enter. Then you have to put in all these numbers. So start with 2, and then you put in a 1, and then your other one. Next row, negative 1, negative 2, positive 1. This matrix looks just like what we wrote down here. Again, notice it's a 2, 1, 1, negative 1, negative 2, 1. When we're done entering in our matrix, we hit second and quit. Then we want to solve the matrix. So again, we hit second and matrix. But now to solve it, we have to scroll over to math. So scroll 1 over to math. And then we're going to scroll up because we're trying to get to RREF for reduced row echelon form. So I'm scrolling up until I get to RREF, which is letter B, reduced row echelon form, and then hit enter. Now it's asking us, well, what do you want me to reduce? One last time, you hit second and matrix. And then you're going to choose the matrix that you just put in there. I always just put it into A, so I just hit enter because I'm choosing to do the reduced row echelon form for the matrix A. Hit enter one more time, and there we go. This is what you get. Now remember, this first column here was the column for A, the second column was the column for B, and the third column was the answer. So this is basically telling you that A is equal to 1 and that B is equal to negative 1. Again, if you look at it, this came out as 1, 0, 1 and 0, 1, negative 1. And this is A and this is B and this is the answer. Therefore, this is just saying, hey, A is equal to 1. And hey, B is equal to negative 1. So the calculator figured out what A and B were for us. After we solve for those constants, we go back and rewrite the integral and then integrate. So we can write this as the indefinite integral of, instead of A, I'm going to write 1. And that's over x minus 2. And I'm going to go ahead and split up the integral over addition. And then instead of B, I'm going to write negative 1. And then still over 2x minus 1 dx. Well, I can factor out that negative 1, so I'm going to go ahead and take that step and factor that out. And now I know that both of these are really just going to be the indefinite integral of 1 over u du. I just need to worry about the coefficient of the x term. Well, this guy here is a 1, so I know I'm just going to be multiplying it by 1, so I don't need to really worry about that. That's just going to be the natural log of the absolute value of x minus 2. But here the coefficient is 2, so I'm going to need to multiply it by the reciprocal of 2, which is a half, and that ends up being negative 1/2, the natural log of the absolute value of 2x minus 1 plus c. So using our shortcut, we were able to integrate quicker, and we ended up with this is equal to the natural log of the absolute value of x minus 2 minus 1/2 natural log of the absolute value of 2x minus 1 plus c. Let's do number 3. Number 3 is x plus 3 over 2x cubed minus 8x. Again, it's a rational expression and it's not basic form, so I'm going to use partial fraction decomposition to get it into simpler fractions. The first thing I need to do is to factor this guy. We'll notice that the denominator has a GCF of 2x, and when I factor out a 2x, I'd be left with x squared minus 4. Well, I can keep factoring that, so I would say x plus 3 over 2x times x plus 2 times x minus 2, because x squared minus 4 factors as x plus 2 times x minus 2. Now I'm going to set up my partial fraction decomposition. So if I rewrite it right here, x plus 3 over 2x times x plus 2 times x minus 2, I know it's going to be, well, there's 3 different denominators. All 3 of them are linear. I have 2x, x plus 2, and x minus 2. And I know that over linears go constants. So I'm going to write a, b, and c. And then I need to multiply through by the denominator. So multiplying by a 2x times x plus 2 times x minus 2. And over here, same thing, a 2x times x plus 2 times x minus 2. In the first one, the denominator cancels, and I'm just left with x plus 3. Over here, all that's going to cancel is the 2x, and that's going to be a times x plus 2 times x minus 2. Here, the x plus 2's will cancel, and that's just b times 2x times x minus 2. And here, the x minus 2's are going to cancel, and that's c times 2x times x plus 2. I'm going to solve for a, b, and c using convenient values. Again, usually I only use a system of linear equations when I have an irreducible quadratic, but if you want to go ahead and multiply everything out and make a system, go ahead, you'll get the same answer. If I'm choosing convenient values, I need to figure out what do I plug into x plus 2 so that term becomes a 0. Well, I would have x equal negative 2. Well, if x is equal to negative 2, I would get, well, negative 2 plus 3 is 1 equals a. Negative 2 plus 2 is 0. Negative 2 minus 2 is negative 4, but I'm multiplying by 0, so that term goes away. Plus b. Negative 2 times 2 is negative 4. Negative 2 minus 2 is negative 4. Plus c. 2 times negative 2 is negative 4. Negative 2 plus 2 is 0, so that term cancels. So you end up with 1 is equal to 16b. Therefore, you know that b is equal to 1 over 16. Next convenient value, what do I plug into x minus 2 so that term goes away? And x equal 2. So if x is equal to 2, well, 2 plus 3 is 5 equals a. 2 plus 2 is 4. 2 minus 2 is 0, so that term will cancel. Plus b. 2 times 2 is 4. 2 minus 2 is 0, so that term will cancel. Plus c. 2 times 2 is 4. 2 plus 2 is 4. So you end up with 5 is equal to 16c. Therefore, you know that c is equal to 5 over 16. Last one we need to cancel is this 2x. So what would we plug in there? Well, we would plug in an x equals 0. Well, if x is equal to 0, 0 plus 3 is 3 equals a. 0 plus 2 is 2. 0 minus 2 is negative 2 plus b. 2 times 0 is 0. 0 minus 2 is negative 2, but that's times 0, so that cancels. c. 2 times 0 is 0. 0 plus 2 is 2, so that cancels because it's times 0. And you end up with 3 is equal to negative 4a. Therefore, you know that a is equal to negative 3 over 4. Now we're going to put these back into the integral and integrate. So we have the indefinite integral of a, which is a negative 3 over 4, divided by 2x. I'm going to go ahead and split up my integrals over addition. So dx plus the indefinite integral of b, which is 1 over 16, divided by x plus 2, dx plus the indefinite integral of c, which is 5 over 16, over x minus 2, and then dx. So here I'm going to start by factoring out all these coefficients. Well, I have a negative 3 over 4 and a 2 there, so negative 3/4 divided by 2, when I factor out all those, is going to be a negative 3 over 8. And this is times 1 over x dx, plus, and then I factor out that 1/16, and then it's going to be times that 1 over x plus 2 dx, and then factor out that 5/16. And then you're multiplying it by that integral of 1 over x minus 2 dx. Well, now integrate. You know each one of those is going to be a 1 over u du, and the coefficient of each one of those x's is a 1, so you don't need to multiply it by anything. So you end up here with just negative 3 over 8 times the natural log of the absolute value of x, plus 1 over 16 times the natural log of the absolute value of x plus 2, plus 5 over 16 times the natural log of the absolute value of x minus 2, plus c. Number 4 is x cubed minus 3x plus 3 over x squared plus x minus 2. Well, this is a rational expression, but I need to be really careful because the degree of the numerator is greater than the degree of the denominator. And we know that when the degree of the numerator is greater than or equal to the degree of the denominator, I have to start with long division. And that doesn't change even if I'm doing partial fraction decomposition. Let's start with the long division. This guy here's my divisor. I have x squared plus x minus 2, and that divides into my dividend, which is x cubed. I don't have an x squared term, so I'm going to write plus 0x squared, and then minus 3x, and then plus 3. And then I have to ask myself, what do I need to multiply x squared by so it becomes x cubed? Well, that's x. I like to line up my terms. Now distribute. X times x squared is x cubed. X times x is x squared. X times a negative 2 is a negative 2x. Then remember, you are subtracting, so you have to change all those signs. This becomes a minus sign, this becomes a minus sign, and this becomes a plus sign. X cubed minus x cubed will cancel. 0x squared minus x squared is a negative x squared. Negative 3x plus 2x is a negative x, and then I bring down my plus 3. And then I ask myself, what do I need to multiply x squared by so it becomes a negative x squared? Well, that would be a negative 1. And then I multiply negative 1 times x squared, negative x squared, negative 1 times a negative x, negative x, negative 1 times a negative 2, positive 2. But then I'm subtracting, so I know I need to change all these signs. This becomes a plus sign, this becomes a plus sign, and this becomes a minus sign. Negative x squared plus x squared will cancel. Negative x plus x will cancel as well in this case, and then 3 minus 2 is just 1. So you know that you're looking at the indefinite integral of x minus 1, your quotient, plus 1, your remainder, over x squared plus x minus 2, the divisor, times dx. Now, I can integrate this, but I can't integrate this yet. This is going to need partial fraction decomposition in order to get it into simpler fractions. So let's handle that and then put everything back into the integral. If I'm handling that little bit, and we're going to do that over here on the left-hand side, the first thing I'd have to do is factor the denominator. So that's going to be a 1 over, and this denominator is going to factor as x plus 2 times x minus 1. Then it's going to equal, well, I have two different denominators, an x plus 2 and an x minus 1. And over each one of those linears goes a constant, so here's an a and here's a b. Then I multiply by the denominator, so I'm multiplying by that x plus 2 times x minus 1, and multiplying here by x plus 2 times x minus 1. Here on the left, everything cancels and you're just left with 1. And then here when you distribute, you will be left with a times x minus 1, and then b times x plus 2. We're going to use convenient factors again to find a and b. This guy right here, what do I need to plug into it so that it cancels? Well, a 1. If x is equal to 1, I know that 1 would equal a times 1 minus 1 is 0, that'll cancel, plus b times 1 plus 2 is 3, so we have 1 is equal to 3b, and that means that b is equal to 1/3. What do I plug into the other term so that it will cancel? A negative 2. So if x is equal to negative 2, I'd have 1 equals a times negative 2 minus 1 is a negative 3, plus b, negative 2 plus 2 is a 0, so that term cancels. So I have 1 is equal to negative 3a, and that means that a is equal to negative 1/3. If we come back over here to the integral that we started, we have the indefinite integral of x minus 1 dx plus the indefinite integral, worrying just about this guy, it's going to be a, which is negative 1/3, over x plus 2 dx plus b, positive 1/3, over x minus 1 dx. Let's go ahead and factor out these constant multipliers, and we have the indefinite integral of x minus 1 dx minus 1/3 the indefinite integral of 1 over x plus 2 dx plus 1/3 times the indefinite integral of 1 over x minus 1 dx. Now integrate. This is going to be x squared over 2 minus x, and then minus 1/3, and this becomes the natural log of the outside value of x plus 2 plus 1/3 times the natural log of the outside value of x minus 1 plus c.